All right, you're good to go,
All
Jeremy.
right. Thank you all. So my name is Jeremy Nelson, and I'm a software engineer at Stanford Universities. And I will be talking about some work that we've been doing on a proof of concept for the FOLIO library services platform backend module called Edge AI. And in Edge AI, it uses large language models to sort of automate the creation of folio JSON records from a textual prompt and uploaded uh, book images. And I'll be demonstrating both of those for you today. Before we go on, I just want to mention that this presentation is actually a website, and you should be able to go to that. It's in the conference description, and also post this to chat here too. Let me see if I can do that. Um, everyone, so here's the actual presentation. A couple of things, just a disclaimer, because I think it's important that I did use ChatGPT and Claude LLMs in preparing and copy editing of this presentation. I also want to mention that a lot of this content and ideas came from a September 23rd pre-conference workshop that I led at for WolfCon. And WolfCon is the um, really conference that sort of the main folio conference. And this year is held in London. And a couple of these topics came from that workshop as well as the first example that I'll show. And there's some links there on this first slide on to getting to that material there. So first off, uh, what is Folio? Folio is an acronym for the Future of Libraries is Open. And it's really an open source library services platform that combines API from multiple backend microservices with a front-end JavaScript single-page application. Academic, public, and national libraries use Folio, either through a managed hosting service or by hosting it on site. Stanford University Libraries, we migrated to a self-hosted Folio installation in 2023. I was part of the team that did that migration to Folio. The Library of Congress has gone live with portions of Folio for their users and staff, but they'll be continuing to do that migration this next year. Some other notable academic libraries include the University of Chicago and Cornell University. And there are a number of other libraries that use Folio. And if you go to the folio.org website, you can see they have a listing there of all the different institutions that do use Folio. One thing I want to mention too, Folio right now is going through a major refactoring where, and sort of to support the Library of Congress's migration, EBSCO, which is a major code contributor and hosting provider for Folio, is replacing some of the core pieces, including a really bespoke or really custom API gateway called a copy. And they're doing that with a combination of more widely adopted open source products such as Kong for the API and then Keycloak for authentication and authorization. Those changes should make Folio more robust and scalable. The next thing I'm going to do is talk about this topic about compound AI systems. There's a link there to a blog post by a group of Berkeley AI researchers who notes the difference between using a large language model sort of as a standalone, monolithic standalone systems versus using them as components in larger systems and that include both large language models and other technology. And they really sort of list some reasons to use compound AI systems instead of relying solely on a LLM. Some of the tasks are easier to improve if the model is part of a compound system. Systems that are sort of these mixture of different components can be more dynamic. There's also is sort of the idea that you can embed as sort of checks on the large language models within your system, so it's easier to control, and trust is easier to establish with these compound systems. And also that with compound systems, performance goals can vary. So that's sort of the approach we've been taking with Edge AI. And right here on the right there is an example of sort of a compound system that sort of where Edge AI sort of fits. It coordinates between the actual large language models, whether it's ChatGPT or Claude or Llama. Then it also interacts with Folio directly, and I'll be demonstrating it. It also interacts with an open source workflow management system called Apache Airflow. And the Apache Airflow will go in a little bit, and I'll show you some demos of that, but that allows us to create more deterministic workflows. And so I think that's where we're really seeing this case where it's really sort of a compound system. Now I'm going to talk about, and you've probably heard from other presentations today, some of the challenges of using large language models. And I want to there's a lot of text here, but I won't go through all of them, but I just want to touch on some of these. And some of these you can account for or minimize, but other sort of these challenges are much broader in scope and are a lot harder to address. So one of the first things that are privacy concerns with large language models. There's problems with maybe personal data in the training data. There's also issues with the organizations that host LLMs logging the prompts and especially if users include personal information in those prompts, then that's problematic as those now are present and persisted. There's also some work done with re-identification of individuals. So even if some of the data is anonymized when you're training the model, there are some attack vectors where you can actually extract some of that identification information. Other challenges include bias with using these large language models, and there's some sources of bias. These include training data, which can over or under sample underrepresented groups. There's also biases in labeling. Algorithms can also be biased, whether they're based on biased data, or some of the programmers can introduce personal biases, whether intentionally or unintentionally. There's problems with using proxies. So if you use a geographic location as a proxy for income, that can be problematic. And there's also cognitive biases where people's experiences and preferences can introduce and favor biases or weighting of outcomes in the selection of data. The next challenge is really about hallucinations. That's a really big problem that's been noted with using these large language models. And it's sort of really based on how LLMs work, which were by generating text, by predicting the most likely continuation token based on the prompt's text, sort of the context that answer is, and also the model's internal weights. And so unlike a deductive process, LLMs do not directly reference their training source material to generate the responses. So they can basically, if the probability for the next token doesn't exist or is not factual, then that's an example of really at the lower level what a hallucination is. And so there's different types of hallucinations. There's fact conflicting, input conflicting, context conflicting, and there's a couple of my mitigation strategies. There's chain of thought, one-shot and few-shot prompts. You can use retrieval augmented generation to provide context examples. And then finally, RLHF, which is reinforcement learning with human feedback, and that's doing some fine tuning. Other sort of challenges, and just because of timing, I'm not going to go into them, but academic fraud and copyright are still real big challenges. And then finally, the carbon footprint of these models. It's really problematic that as you know, we as a civilization try to respond to climate change, that suddenly we have these technologies that are consuming and demand huge amounts of energy, and how do we sort of balance that with some of the functionality and usage that we can get out of this. So next, I'm going to go over, and I'm actually going to run this locally. So I have a locally running Edge AI API running on my local laptop. And I'm going to show you an example of how we are going to generate an actual um, beginnings of a folio record within folio. So here I have just a cataloging problem. I grabbed this from the New York Times bestseller, nonfiction bestseller. So in this case, it's really the idea is that the cataloger can have just a textual prompt that's a conversational of what they would like to catalog. And whether that prompt becomes through this, which is really just a little web widget, or a Jupyter notebook, or you could do it from the command line, or a more sophisticated user interface. You can have all these different ways to actually create or prompt a model to generate a Folio instance. So I'm going to go ahead and do this. And here we can see so the Edge AI prompted, in this case, ChatGPT, and along with, we used a one-shot prompting example. So we provided an example in the prompt, and you can see here, this brought back this sort of stub record. And then what happened, and what does the Edge AI does next is send it to Airflow. And Airflow basically takes the stub record, sort of expands some of the instance types into using the UUID of the reference data, and then tries to do a match on a small RAG data store that we have. And if it doesn't find a match, then it actually posts that record to Folio. And I'm using here, I have a link there to a snapshot. So this is a community snapshot. And if now we do a search, and then we will actually see I'm going to cheat here and show you. So there's that record I just created in Folio. You can see there's the title. We have the publisher, some of that information that was extracted from the prompt that we gave it, as well as, if you look here, yeah, there's the title. Do I see the contributors? Yes, and there's so the author there as well. So this is just one example where using from a brief prompt, we're able to create a record in Folio, and then, the idea maybe then the staff can go in there and fill that out in more detail. Certainly, we could put more detail in the initial prompt to do that, but in this case, this is just a brief example. Now, the next the next example I want to show you is actually uploading a book, in this case, a cookbook cover that I took a picture of. Excuse me. So we're going to basically run the same workflow. So I'm going to go ahead, select that cover, upload it. And this might take a little bit of time. And then we can go here. We can see here's the actual running DAG. And excuse me. There it is. So there we have the instance record that extracted that information from the image itself. And then if we go back here, let's reset. And then search. We can actually see there is the record that we created or we uploaded. So there's an example of what I wanted to show you of using the large language models and the Edge AI to do this prompting and actually creating these things. So what are the next step? Well, I mentioned before that we're using RAG to help provide the better context for these prompts. in this proof of concept, we're using a open source project called Ragatui, and we've had mixed results with that. I should mention that since Folio and Airflow use Postgres database, we're thinking about our next RAG iteration to explore using the Postgres extension PG vector. And so there we'd actually create a vector of all the records, and then we would use some semantic search to provide that context that is then sent to the model. Another option would be to use the Folio search engine, which is now Elasticsearch or open source, but that's really restricted to just inventory records. And we would definitely want to use other types of records in Folio for things like invoices, orders, or circulation policies, which currently the Elasticsearch doesn't support. Another thing we're looking at with Folio is doing function calling. And there you can set it up so that your large language model returns back a function call. And so what's interesting with Folio, and one of the advantages of Folio, is that all of the backend modules actually have exposed API endpoints. Well, currently there are 1,500, and I think it would be a really daunting task to try to manually add those all to Edge AI to be able to use. Some preliminary results was actually using an LLM to generate those functional uh, 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 definitions as part of the Edge AI, so that would help us keep Edge AI current with the available endpoints in Folio. And also, as new endpoints are added in future releases, we would automatically pull those up. Another idea that I'm looking at doing is the possibility of creating dynamic DAGs. And so a DAG is a directed acyclic graph that Airflow uses. And so it's interesting to think about what would like a custom workflow would look like if you have a sort of a novel prompt. Could you set up Edge AI to generate based on sort of the function calls a workflow that does that for different types of use cases beyond just inventory. And so finally, um, I want to do a plug for a group I'm a part of as a co-chair, the AI for Lamb, which is a community. It has a metadata working group, and we cover a lot of the things here that I briefly touched upon in that working group. Usually we meet on the second Tuesday of every month, and that's actually helped us develop and work on both the Edge AI and the AI workflows for that. Some quick lessons. I think from this work is the best is learning from experimenting and iterative development. And because the Edge AI crosses so many different contexts and system domains, starting small and then adding additional functionality and having people test and work with it has been really helpful. So with that, thank you all. And I guess we have 1 minute for questions. And I will look in the questions thing. Yep.
Yes, if y'all have any questions for Jeremy, please post them in the Q&A. He'll stick around for a little while post-session and answer any of those that may come in. Thank you, Jeremy. It was a great presentation. Appreciate it.
Thank you all.